This video is going to look at the Poisson distribution, specifically the inverse problems of a Poisson distribution. Now, there is actually only one inverse type of Poisson question, and I'll show you why. Here's our formula for our Poisson distribution. Our e, the natural number, is to the power of negative lambda, or our average, multiplied by lambda to the power of x and all over x factorial. So we need to make sure we know what x is and we know what our average over an interval is to find the probability of success. The inverse Poisson gives you the probability of our event happening, and it actually misses out lambda or x. And x can be solved from the graphics calculator. However, again, it's never been seen in an exam like the binomial, because if you have a value of x, it's actually a lot more difficult to solve without a graphics calculator, so they've never actually put it in. A question, therefore, is always asking for lambda and will always give you a value of 0, much like binomial. And what happens to our formula when that happens is that anything to the power of 0, so lambda to the power of 0, is equal to 1, and 0 factorial is also equal to 1. So in essence, when we have the probability of x equaling 0, it is actually equal to the natural number e to the power of negative lambda. So we're actually only ever going to be finding the average over the interval. So we get given the probability at x equals 0. We know that x equals 0, and therefore the missing value is lambda. The probability of x being e to the negative lambda means that we always need to bring the power, to solve the power. And we remember that solving the power uses a log. However, because we're using e, the natural number, we actually need to use ln for our log, which is our natural log. Okay, so the opposite of e to the power of x, or in this case e to the negative lambda, is actually ln, the natural log. So we need to take the natural log of both sides, and so in this case we'll see that ln cancels e. So we have the natural log of the probability of x equaling 0 equals a negative lambda. Therefore, lambda is equal to the negative value, it stays over here, the negative value here, is the negative ln of the probability of x equals 0. Now, it is the negative value because if you type ln, or you use the natural log of the probability of x equals 0, you'll actually always find you end up with a negative number, and we require a positive number, so we're always going to multiply it by -1.